So all of section 4.4 is finding values for any angle. So that's really what 4.4 is kind of talking about. And this part here, talking about a reference angle, it says values of trig functions at angles greater than 90 or less than 0 are determined using the values at corresponding acute angles called reference angles, which is kind of what we did when we looked at the unit circle. We just didn't give them a formalized name. So a reference angle is a specific angle that we use to help us, kind of guide us to find the correct value for an angle bigger than 90 or a negative angle. And again, that's what we've been doing. We just didn't give it a formalized name. But it is an acute angle. Remember, it means it's less than 90 degrees. So less than 90 degrees. And it gets a special notation. So if my regular angle is theta, a reference angle gets a little like apostrophe, and that's called a prime symbol. You will use a prime symbol. We'll use it at the end of the year, but you'll use that prime symbol a lot in calculus. But it references your original angle. So it's kind of duration, not a duration, but like a piece or part, a relation to the original angle. So an acute angle, theta prime, formed by the terminal side of our angle. Everything goes with that terminal side. And the x-axis. And the x-axis part is really important. Everything is from the x-axis. It never goes from the y-axis, because the x-axis is our standard position. That's where we start our angles. So I'm going to draw you just a couple little diagrams underneath, because you have a little bit more space. Because there are a couple of different ways that we can have a reference angle, just so you can understand what we're looking at visually. So 3 different cases, because it's angles that are bigger than 90 degrees. So my first case would be an angle that would be in the second quadrant. So here's my angle, bigger than 90 degrees. So a reference angle, and I'm going to put positive here. So cancel out the and. We'll say a positive angle. Positive is important too. Is formed by the terminal side of the angle and the x-axis. So the reference angle is the little angle sitting right here, connecting the x-axis and the terminal side. That's our reference angle, which is really what we use to make a triangle. We call that theta prime. So to find it, if it's over here next to pi, I would take pi minus my original angle. That's how I calculate. So my original angle is less than pi, so if I start with pi and subtract that original angle, then I would have the reference angle. So a second option would be an angle in the third quadrant. So here's the original angle. The reference angle is the angle that connects the x-axis and the terminal side. So it's always going to be acute, less than 90 degrees. And it's pretty much like how far past the horizontal axis did you go. So to find this angle, I would take pi. But instead of subtracting, I would actually start with the angle. So my original angle minus pi, because the original angle is past pi, would equal our reference angle. So I'm using pi in both cases there because I'm next to pi. The angle is located next to pi, above pi or below pi. And then the final option would be an angle in the third quadrant, all the way around. So here would be my reference angle. In the third quadrant, it's also a coterminal angle. So in this case, it's not quite at pi. So I would subtract the angle to get my reference angle. So 2 pi minus the angle is the reference angle. So that is really finding a coterminal angle as well. But it's always a positive value. So reference angle connects the x-axis with the terminal side. So it's like that little extra piece. How far did you go past the x-axis? So down below you have 4 problems. And those 4 problems want you to find a reference angle. So sketch the original angle, and then we'll also sketch the reference angle, and it says to find it. So if you want to draw a circle, you can draw the circle. If you just want to draw the xy axis, that's fine as well. Really, there isn't a visible circle embedded on top of each one of these axes that we draw. So Carrie, where would 150 degrees be?
It ends in quadrant 2.
Yeah. So 150 degrees is in quadrant 2. So there's my sketch the angle. There's the angle. So Carrie, the reference angle would be located.
Quadrant 2.
Yeah, and it's just underneath. So the reference angle is underneath. It's this little angle here. So how would you calculate that, Carrie?
180 minus 150.
Right. So our reference angle is 30 degrees. So I need an extra 30 degrees to get to 180. Essentially, that's what it's saying. So it's the little piece left, the angle left in the diagram. So the second one, negative 135 degrees. Nick, where would negative 135 be located? Where would 135 be located?
My bad.
That's all right.
Third one.
Yeah, third quadrant, and if it's negative, it goes.
What?
If it's negative, what direction does it go?
It's gonna go like this one.
Yeah, it's gonna go underneath.
Yeah.
Yeah. So there's our angle. So the reference angle connects the x-axis with the terminal side. That's where my reference angle would be. How would you find that?
So would it be the original angle minus 180?
So you take the original angle,
Yeah.
but because that original angle is negative, instead of subtracting 180, we're going to add 180. And that's because the original angle is negative. So if I subtract 180, then I'm going to get a bigger angle, and it's supposed to be an acute angle. So Nick, negative 135 plus 180. Why is she calling on me?
Yeah, you keep going. It'd be third. Wait, my brain ain't working today. My bad. 45.
There we go. Nice. Any questions on the degree angles? So a reference angle is really an angle in the first quadrant. It's that 30, 45, 60 degree angle. That's what a reference angle is. 2 other ones down here. So we have 9 pi over 4. Garrett, where's 9 pi over 4?
Would that be the third quadrant?
So if we count to 9 pi, 4,
Oh,
8,
the first one.
it's the first quadrant. Here's my 9th piece. So this angle spins all the way around once and then it continues. So Garrett, what would the reference angle be then?
Would it be pi over 2?
Not pi over 2. How far past? How many pieces of the pie did you go past?
1.
And the denominator is 4. Yeah. So my pie is divided up into 4 pieces on the top, 4 pieces on the bottom. We went 1 pi over 4 past 2 pi. So you could have also said take your angle and subtract 2 pi. That would have been another way of thinking about it. The last one is 2.3, which is a decimal radian value. Don't put a pi next to it. The pi is already in the number 2.3. So I don't need to have like an extra pi to it because that changes the value of the angle. How do you know where to graph 2.3? So this is a radian value because it doesn't have a degree symbol. We don't need to convert it to degrees. We know this is typically pi, and this is typically pi over 2. What is pi over 2 as a decimal? So if I have this angle as a decimal, what is pi over 2 as a decimal? So what is pi divided by 2, Josh? Yeah, and Josh, we know pi is 3.14. So pi over 2 is 90 degrees. But as a decimal value, it's 1.57. So where would 2.3 be located? In the second quadrant. So if you're given a radian that's a decimal, you need to think of your radians as decimal values as well. So this is going to be in the second quadrant. So here's my angle. So the reference angle is that little angle, acute angle. Lauren, how would you calculate the reference angle? Yeah. And what do you get? 0.84. And again, that is a radian value. It's just a radian value that's in decimal form. So it's a decimal radian value instead of having a pi over 4, pi over 6, and pi over 3. It's a decimal value. Questions? So reference angles are useful, as it says at the bottom, because we can evaluate trig functions using reference angles. So it says, to evaluate trig functions at any angle, determine the function's value for the reference angle. Attach an appropriate sign, meaning positive or negative, depending on the quadrant that it's located in. We've been doing this. So when we look at an angle and look at the denominator, that 9 pi over 4, the denominator tells us it's a pi over 4 angle. It's in that family. Every pi over 4 angle has the same ordered pair. We just didn't call it a reference angle. We've just been saying that it's this group of angles that are related, and all of them have the same ordered pair. It's just we have to decide where is it positive or negative because of the quadrant that it's located in. So at the top of the next page, like this is stuff that we've done. You can look in your notes for section 4.2. You can look in your notes for section 4.3. These are the same exact questions. So it really is just repeating it, giving it a fancy name. So this wants you to evaluate the angle. And we have the 4 pi over 3. We just want to find the cosine of it. So based off the information, we're going to sketch the angle and see if we can kind of figure out the ordered pair that is correlating or associated with this value. So draw yourself in a circle. 4 pi over 3 means my circle has 3 pieces of pi on the top and 3 pieces of pi on the bottom. So Reese, where would 4 pi over 3 be located? Yeah, counting to 4 pieces of the pie. So because the denominator is a 3, we're really thinking about a pi over 3 angle. And we want the ordered pair that goes with a pi over 3 angle. So this is still a unit circle. A unit circle will not vanish until we're done with trig, and then you'll use it a lot in calc. So what is an ordered pair with pi over 3? Do you know, Reese? Nice. So they're both negative because it's in the third quadrant. So then, Reese, what is the cosine of that ordered pair? Perfect. That's all you're doing, which we've already done. Doing it again. So the second one, negative 210 degrees. So now instead of having a radian, we have a degree. Dylan, where is negative 210 degrees? Negative 210 degrees. Where would that be located? Quadrant 2. So we have to pass negative 180 to get to quadrant 2. So Dylan, what would the little angle be, that reference angle, How far past 180 are we going? 30 degrees. So if I have negative 210 and I add 180, I get negative 30 degrees, but a reference angle is positive. So we're really talking about a 30-degree angle. Dylan, one more question. Do you know the ordered pair that goes along with a 30-degree angle? Anybody remember the ordered pair that goes along with 30 degrees? Hannah?
5 square root of 6. Wait.
Oh, yeah, you're giving me the radian value.
Oh,
What's the xy value?
negative 3 over 2.
There you go. Negative 3 root 3 over 2 and then 1 half. So, Hannah, how would you find the tangent using that point? Yeah. Nice. Sine over cosine, y over x, however you choose to think about it. So my 2's cancel. I have a 1 over negative root 3, so that simplifies to negative square root of 3 over 3. And then the final one here is that 9 pi over 4 angle, which we actually graphed on the previous page. Carrie, where did we say 9 pi over 4 was?
Quadrant 1.
Quadrant 1. So 4 pieces of the pi, spinning around all the way, and then going an extra piece. And we said that was a pi over 4. So carry the ordered pair with pi over 4 in the first quadrant.
That's square root of 2 over 2. Square root of 2 over 2.
How would you get the cosecant?
You do the sine of 9 pi over 4 is square root of 2 over 2. And then you take the reciprocal of that.
Perfect. So we need to use the sine value, and we need to take the reciprocal of it. So we have to flip that value. So that's going to be 2 over the square root of 2. And what does that simplify to be, Carrie?
It's square root of 2.
Yeah, just the square root of 2. So you need to find the sine, which is the y value. Cosecant is the reciprocal of the sine, so that means flip it over. Any questions with those 3 problems? So this is going back to the unit circle, thinking about the ordered pair that is attached with that angle. So where is it located? Positive versus negative, x, y, and then evaluate the piece given to you. Questions? So I am going to skip example 3. This is similar to the warm-up that we did. So draw a triangle with the sine being 1/3 and in quadrant 2. And then you're finding the functions. This is pretty much like your homework last night. So I'm going to skip this because I want to talk about the last example. Which we did a little bit in section 4.3. So this one says find 2 values of theta in degrees from 0 to 360 and 2 values of theta in radians from 0 to 2 pi. How many answers should we have? 4. What are we trying to solve for in this problem if we're finding theta? What's theta mean? Angle. So here we are finding the angle. This is the opposite of the 3 problems that we just did. So the 3 problems we just looked at, we knew the angle. We were trying to find what it was equal to. Now we're going to kind of go backwards and think, okay, we have a cosine value. What is attached with that cosine value? What angle goes along with that? And it says 2 in degrees and 2 in radians. So we're going to have 4 answers. So this is like the backwards of the unit circle. So the first thing we have is cosine. Cosine x or y, Quint. Colin. By your last name. Colin is cosine x or y? X. So this is my x value. And that x value is positive or negative? Colin.
Positive.
Okay. So if we have a positive square root of 2 over 2, where is x positive at?
First quadrant.
Right. So I know we have a positive x in the first quadrant, and we have a positive x in the fourth quadrant. I also know that the y is positive in the first quadrant, but negative in the fourth quadrant. So that would be my ordered pair. What angle goes along with that ordered pair in the first quadrant? Colin. Say again. 45 degrees. It's a 45 degree angle. And as a radian, Colin, it is pi over 4. So now I want that same angle, but we want that angle in the fourth quadrant because there's also another time when cosine is the square root of 2 over 2. So how would you get that angle in the fourth quadrant? If I know in the first quadrant it's positive 45 degrees, how would I find it in the fourth quadrant? Gary, want to take a shot?
Subtract that angle from 360.
Perfect, yeah. So if I need it in the fourth quadrant, it has to be less than 360. So we know it has to be less than 360 by 45 degrees. Garrett, what is 360 minus 45 degrees?
315.
Nice. Do you know what a 315 degree angle is as a radian?
Is that 7 pi over 4?
Awesome, nice job. So now I have 2 answers, and I have 2 answers. 2 in the first quadrant, 2 in the fourth. All right, let's see if we can try this again. So B, the sine is negative square root of 3 over 2. Brenton, is sine x or y? Y. Where is the y negative, Brenton? The fourth quadrant. And where else is y negative? The third. Brenton, do you know what x value would go along with these ordered pairs? Yeah. All right, here's the tricky part. If this is my ordered pair, I need an angle that goes along with that ordered pair. So just think first, if that ordered pair was in the first quadrant, what angle would it give you in the first quadrant? Emma? Say it again. 60 degrees. So my angle in the first quadrant is a 60 degree angle, or pi over 3. So your homework, part of it, the last couple of problems, is going to be like thinking backwards. Draw yourself a little diagram and see if you can kind of think of what angle would correspond with the information given. So that would be like a 210 degree angle. I'm sorry, not a 210, a 240 degree angle.